Hi, I'm Nithya.
And I'm Mika.
And we sorted you.
Want to go to Hogwarts?
You can't.
But pretend for a second you could.
Where would you belong? Would you belong in Hufflepuff?
Where they are friendly, loving, and selfless?
Etc.
How about Ravenclaw?
Where they are curious, imaginative, and wise. Maybe Gryffindor.
Where they're daring, fiery, and adventurous. Or maybe you're a Slytherin.
Where they're mysterious, clever, and ambitious. So, Mika, how would you frame this as an optimization problem?
Well, Nithya, the decision variables would be which house each student was sorted into. The objective function would be to maximize the students' results in a survey that correspond to their placement into a house. Subject to the constraints that each student can only join one house, and each house must have an equal number of students.
The way we set this up was we sent out a survey, and each answer of the survey corresponded to a particular house. And in the example, it shows which answer was for which house. And using the survey responses, we could make up a matrix R where each row represents a student and each of the numbers in these rows corresponds to the survey questions and represents which of the four houses that particular student's answer corresponds to. We use this information to make up the matrix H, where the rows represent each student and the columns represent how many answers they gave towards each house.
Okay, so at the end our solution would be a matrix hat, with each row representing a student, and with 4 columns, 1 for each house, showing which house each student was sorted into. Linearity has an output vector x, which gives us this information in a long column vector which is made up of 4 values for every student. If you took every row of hat and turned it into a column and appended all the columns together, that's what x would look like.
The first constraint is that each student must be sorted into one and only one house. And int linprog needs constraints in the form of aub times x, which is the solution vector, equals bub. And to frame this, if you look at the first row of aub and multiply that by the column vector x, you can see that the value of that multiplication would have to be 1 if the student was sorted into just one house. And each following row offsets the ones by a multiple of 4, since every 4 numbers in the column vector x corresponds to a student. So when the entire matrix AUB is multiplied by the column vector x, the vector BUB needs to be a column vector of 1s, and that way we make sure that there is only one in every 4 elements of x, meaning that each student is sorted into only one house.
The second constraint is that each of the 4 houses needs to have a quarter of the total students. A times x allows us to basically count the number of students in each category. Each row of A counts a different house, and using B we can set that to a quarter of the total students. Inequality constraints for int linprog are in the form A times x is less than or equal to B, and we needed A times x to be greater than or equal to B since we wanted there to be at least a certain number of students in each house, which we could set using B. So that's why we use negative values in this constraint. B has a length of 4, and it was telling int linprog that each house needed to have at least 15 students since we had 63 students respond to the survey.
This is just an overview of what int linprog takes in, and it takes in obj, which is the negative transpose of the H matrix, and the reason that it was negative was because we wanted to maximize the matches rather than minimize the matches. And the H matrix was just the rows corresponded to the students and the columns corresponded to the number of responses corresponding to each house. And intcon made all of the values of the solution vector x integers, and it also takes in the constraints a and AUB, B and BUB, and a lower bound and upper bound, which we set to 0 and 1 because we wanted zeros and ones to come out in the x vector.
So when we plugged our constraints and objective function into int linprog, it spit out the vector x that we expected, with every 4 values corresponding to each student, displaying which of the 4 houses they were sorted into. Now all we needed to do was append each set of 4 values to a row so that we could get a matrix hat that would more clearly show the results. Are you ready for the results?
Drum roll, please.